evening, students.
Good
Good evening,
evening,
sir.
sir.
Good evening, sir.
Someone mic is on. Just 1 minute. किसका mic on है? So today we are going to start clamper circuit. Okay. So put the heading diode clamper circuit. Now what is diode clamper circuit? Diode clamper circuit, okay, will shift your signal upward or downwards. It will shift the level of the signal. Okay. Shift the.
Sir,
Yes. Just 1 minute.
recording.
Okay. So your diode clamper circuit will shift the level of signal. Okay. Either upward or downward. So it will not distort the signal like in a clipper circuit. Okay. Clipper circuits clip the some portions. So it will not clip. It will only shift the level of the circuit. Okay. The signal. So for example, there are downshift clipper, they are upward clippers. Okay. We'll call negative shifter or positive negative clamper or positive clamper. So let us see the example of a negative clamper. So for example, so in the clamper circuit, you always will have a capacitor. Here you have a diode, and here you are applying signal. Okay, this is your V input signal. This is your capacitor. Okay, let us call diode is ideal. I am putting a resistance across this resistance R, and I am taking the V output here. Now, for clamper circuit, one condition should satisfy that RC constant of the circuit should be greater than the time period of the signal. Okay. So whenever RC constant is high, okay, the decay of the capacitor becomes slow. Okay, and it maintains the voltage for longer period. For example, I am applying here is V input a sine wave. Okay, so say I am applying a V input which is Vm sine omega t, and this is my signal. Now, as time passes, this capacitor gets charged. Okay. Now let us say this is the time one time period t. This is t by 4. Okay, and then this is t by 2, and this is finally this 3t by 4, and this is time period t from 0 to t time. Okay. Now capacitor will charge for positive cycle. Capacitor will charge. Here will come positive voltage. It will come negative voltage. Okay, and now current has to pass. So current can pass through here or here, but current will always choose a path which has a lower voltage drop where resistance is less. Okay, so for example, generally we keep this resistance very high load. Okay, we don't want to pass this current to from here. Of course, here voltage drop will be there. If it is a silicon diode, 0.67 voltage will be there, but resistance will be high, so current will pass very less. Current will pass from here. Okay, so voltage drop here will be less. Now, if it is ideal, so voltage drop will be here 0. So obviously, if I'm saying this is ideal, so here voltage here this will be behave like a short circuit or positive cycle, and here there will be no voltage drop because the voltage is 0 here, voltage is 0, so no current here. So all the current passing through this capacitor and capacitor getting charged. Okay, so up to now this is charging, and when it is charging, it will charge up to the maximum voltage Vm. Maximum voltage it will charge Vm. Okay, and during when it is charging, this diode is forward bias, so current is flowing here. Diode is short circuit and current is flowing like this. Okay. Now what happens once it will become completely charged? Okay. Now this voltage Vm is behave like a battery. Now it is a capacitor. It is a voltage. Now it can also discharge. So it is a behave like a battery of voltage Vm. This Vm is always greater than this one. Maximum it can be equal. Now this voltage is always greater than Vm sin omega t because it's a peak voltage. So ultimately what happens that now in this circuit, this diode will become in reverse bias because now it is connected to the minus. Okay. So effectively it's minus Vm. So Vd will become negative. Whenever if I want to calculate Vd here, suppose if I want to calculate Vd here in this capacitor, so Vd will be what? Vi minus Vd will be, this is minus Vi. If I start like this, minus Vi plus Vm plus Vd equals to 0. Vd equals to Vm plus Vi minus Vm, Vd equals to minus Vm plus Vi. Now Vm is always greater than this V, or either it can be equal, or this is always greater than this Vi. So that means now Vd will become negative whenever it charged completely. Okay. So current passes in the circuit for only for t by 4 times, t by 4 times. Now once it is completely charged, now it doesn't happen in the one cycle. Okay, it takes some few cycles. Now negative cycle what will happen? Negative cycle, this will be always reverse bias. Positive cycle is positive bias and charges up to some voltage, say not Vm, it will charge some to Vm by 2 or Vm by 3, it charges. And now what will happen? Negative cycle, this will go here, this circuit is open because this is open and current passes through here. But for now voltage, maximum voltage drop will be here because it's high resistance. Okay, maximum voltage drop here, there is so negative, so it will try to charge negatively. Okay, but that will be lesser than this voltage. So ultimately what happen for a few cycles, say 1 cycle, 2 cycle, 3 cycle, 4 cycle, 5 cycle, this will be completely charged. Okay, and now no effect will come, and this diode will get permanently open circuited. Okay, so for doing the clamper circuit, you should always remember what I'm telling. As soon as you see the capacitor and diode, first thing, diode will be always in open circuit. Okay, and capacitor will charge, and you how capacitor will charge depend how the diode is placed here. Okay, now diode was placed like this, so it's charging the forward cycle. It may charge in the negative reverse cycle also if the diode is oppositely placed. So now it's coming plus minus Vm here. If the oppositely charged, it can plus minus Vm come like this. Okay. Now negative cycle you should not see. Okay, because now once it is charged, completely charged, now it cannot decay because the RC time of the circuit is very high. So this is a one time period. But discharging fully, it will take 5 RC. So until one more cycle will come, it will charge. Okay, suppose it's charging, it's a little bit decaying, it will not decay. Okay, it will not decay because this will not charge negatively because here voltage will be always greater than the opposite side. So slowly it will charge, and once it is charged, now it will not decay because RC time is circuit is very high. This is the condition for clamper. Condition for clamper. So now this is the final condition. Now this final condition you have to write the what is V output. Okay. Now let me write the V out. This is open because open. Now what will be output? V output will be, or you write here in this cycle you write this. I'm applying V input here. I'm applying Vm here and plus minus V naught. I'm writing V naught here. This is equal to 0. I want V naught. V naught will be Vi minus Vm. Okay, now just you keep on putting the value of, now this is your input signal. This is my input signal. Okay, so input signal Vm omega t. Now I'm going to draw the output signal V naught. Okay, now what will happen? You put Vm equals to 0 here, V input equals to 0 here, so it will come minus, so V output come minus Vm. Okay, minus Vm, so it will come minus Vm here. So this positive cycle minus Vm, and then you put V input equal to Vm. This come to 0. So when it is a maximum, it will come to 0 here. Okay, and now again you come down. Now when it is 0 here, it will come negative, again negative, and it is a negative minus Vm. It will come minus 2 Vm. So your circuit will go like this. So this okay, and when it is 0, it will go to the again this. If it is 0, it's up to minus Vm up to here. Okay, and this way it will keep on doing, keep on going. If it is goes, then it goes like this. When it become again positive, when it become positive here, that time this will go to 0. Okay, now signal is not distorted, only the level gets shifted. Okay, here it come downward. So this is the example of your, so this is your output signal now. Okay, so it is shifted by how much? Vm minus Vm. Okay, so this is the
So,
example of negative clamper. Tell me.
sir, for the first half of the positive cycle, the V out should be constant, na? Like 0.
You see, you keep on up. This is the equation now. This is our equation. It is not charging. It is keep constant. This Vi is varying. V not to vary. Okay, this is the equation.
For positive first half.
Positive half side.
For,
This is 0.
huh.
The output will come what? Minus Vm.
No, no, so at that time the capacitor was not charged.
Capacitor will this signal will come whenever capacitor charge. This happens in the very few microseconds.
Okay, okay.
As soon you connect it, okay, the circuit gets stabilized in this way. Okay, and
Okay.
now you are having you. So that's why I told you, you always have to put sign here, plus minus minus plus. That for that you have to see which direction it is getting charged. Okay. So after this circuit is same for every circuit clamper do this like the same way. Now you just keep on putting the Vi value positive. You put positive cycle, negative cycle, whatever you want to put, or either you just put the Vi values here. Okay, this will code like this. Clear? So for positive cycle, what is the value of maximum? For positive cycle, Vi go up to Vm and Vm. So this is the peak. Peak means maximum value. Maximum value. Positive cycle when Vi is Vm, V output will be 0. When Vi is Vm is 0. Okay. And for negative cycle, when V output V and V input is minus Vm, V naught is minus 2 Vm. It's minus 2 Vm. It's simple. Okay. Don't think anything much. If you understand this one, you can do every problem of clamper within a seconds. Okay. Let me tell you some more examples. It is clear to everyone? Swaparnika, Rajveer.
Clear, sir.
Okay. Now let me just modify a little bit more circuit. Okay. So I'll be keep on doing now negative clampers first. Okay. Then we'll do positive clampers. This is a negative clamper. Okay. So this is a negative clamper. Diode is like this, and let me put a battery here of VB. Okay. The story is same. Okay. Diode, the signal will shift always in the direction of current. If current is moving like this, the signal will shift down. If current is moving like this, the signal will shift up. That you have to remember for all the clamper circuit. Now current is flowing down, it will shift down, but how much down, that will decide now. Okay. So always again, if you put a diode here, same thing will happen. It will charge. Okay, it will charge. But how much it will charge now we have to decide, because now here battery is there. So when current is flowing, this will become short circuit. When current is flowing, this will be short circuit. So now you have this Vi, and this is you have a Vc, and now this is your plus Vb in this circuit equals to 0. So how much it will charge? Earlier there was nothing. battery, nothing, nothing resistance, everything, nothing was there. So charge up to the VM. Now here VB is there. So now VC will be what? VC will be your VI minus VB. So now capacitor will charge again in the same direction. Okay, but voltage will become VI minus VB. And once it is completely charged, okay, this circuit will get open, this it will get negative, because this voltage is this voltage is always greater than these two voltage. Okay, VM charge up to maximum voltage VM minus VPI. Okay, I'm taking the maximum value of this one. So capacitor will charge up to VM minus VPI. Now this voltage is always balance this one, and this will go open, so you can remove the circuit because it's open, nothing is there. Okay, now again, this is first you have to find the capacitor voltage. Now you have to again apply the same circuit. Now what will happen? You have to apply minus VI plus VC is VM minus VB, and plus V naught equals to 0. And now you can find the V naught will be your VI minus VM minus VB. Okay, now just keep on putting the values of input signal, and you can find the output. Draw the output. Tell me how it's coming. Draw the output. Keep on putting the values and tell me what the output is coming. How much is signal is getting down, up? So let us put now values. So here I have the signal. My VM.
Sir, your voice is low.
Just 1 minute. V output. Is it okay now?
Yes, sir.
Yes, sir.
Okay, now put the values. Put V input 0. If V input is 0, then this will be what? Minus VM minus VB. Okay, it will be somewhere here. Minus VM minus VB. VM minus VB. And when Vi is VM, then it will come to the positive VB. And when this is maximum, it will come to the positive VB. Okay, and again you have to put 0. When it is become 0, again it will come back to here. Okay, and when it is a minus VM, then minus 2 VM minus VB. It will go down further, and this will be what? Minus 2 VM minus VB. Okay, or difference should be 2 VM minus 2 VM, VB minus 2 VM minus VB. We cancel, the difference is 2 VM always. Okay, so signal is not distorted, and again it goes to 0, so it will come here. And for next cycle, okay, it goes like this. So drawing the clamper circuits is very easy. So this is again, so we have put positive voltage little bit, so the shift is slightly less. Okay, clear?
सर ये ग्राफ कैसे ड्रॉ कर रहे हैं हम, वो थोड़ा समझ में नहीं आ रहा, और ये कैसे शिफ्ट हो रहा है, डिस्टॉर्ट कैसे समझ आ रहा है वो।
हाँ, ये ग्राफ में हम V आउटपुट हम वी आर यूजिंग दिस इक्वेशन. Okay, we are putting the V input value here. V input is what? 0. Well, first going 0. If we put 0 here, V naught will be what? Minus VM minus VB. Minus VM minus VB. VM थोड़ा ज़्यादा नीचे होगा. Minus VM is slightly less than, but because this is what? Minus VM plus VB. So minus slightly is there here. when it is goes to Vm, you put Vm here. So Vm minus Vm 0 plus Vb. So it's come plus Vb. When it goes minus Vm, V output goes minus 2 Vm minus 2 Vm plus Vb plus Vb minus 2 Vm plus Vb. अभी clear है?
Yes, sir.
Okay, so this is the final equation I'm writing. So clamper means first you decide what is the voltage at capacitor. ये decide हो गया. What is the, so this is the capacitor voltage. You put it here. Now you write the KVL. This is the final equation, and here you just have to vary the V input, and accordingly you have to draw. Okay. Okay. So if current is flowing like this, then signal will always go down. How much it will go, battery will decide. If current is going like this, signal will go up. Okay. Now let me put one more case here. I am putting diode here and I am putting battery here. Now battery I have changed. Now again this is VB, but I have changed the sign. Okay. Now tell me what will happen. Tell me what is the VC. Now this time what is the value of VC? Again, capacitor can charge only like this, so voltage will come like this only. Okay. Now tell me what is your VC. So this is minus. This will charge up to maximum voltage of this one. Okay. So I'm taking dependent when this is the maximum. I'm taking minus Vm. Okay. And I'm keeping this is a VC plus VC. Okay. And when current is flowing, this is short circuit. And the voltage is here minus VB. Okay. So VC will be minus Vm minus VB. So this will charge up to minus Vm plus VB. This will charge now. This will charge like this. And once it is completely charged, again you make it open. Make it open. Okay. Again you write the equation here. Okay. Now I'm writing V input. This is minus V input, and this coming plus, but this is minus is there. So minus Vm plus VB. Okay. Oh, this come plus or minus?
VC is Vm plus VB.
Vm plus VB. Vm plus VB. Okay. Vm plus VB. Okay. And then your V output equals to 0. So V output will become now Vi minus Vm plus VB. Again, put the values here. Okay. So when it is 0, this is your minus Vm plus VB, slightly greater than your this one. This is this one. Okay. And when it is plus Vm, then it is minus VB. When it's plus Vm, Vm minus Vm 0 and minus VB. So now it will come up to here, minus VB. So shift become more. When you put negative battery, shift become more. Okay. And again, for 0, it will come back to here again. Okay. And on negative, minus Vm. So minus Vm, minus Vm, minus Vm, minus Vm2, minus Vm2, minus Vm, and minus VB. So it will go further down. It will go up to come back here. So this will be how much? Tell me. Minus 2 Vm plus VB. Okay. And again it will come here. Come here. That means when it is maximum, it is here. When it is when it's 0, it is here. So I'm plotting wrongly. Okay. So when it is 0, when it is minus Vm, it is going here. And then it is 0, it's coming here. And when it is here, this is going to up to here, minus Vm. This you have to keep in mind. Signal will not distort. Okay. So you have to draw properly. Signal will not distort it. It will remain sine wave only. So these are all example of negative Okay, negative clamper, because there's no further choice. Now we can only do with one diode. We can do like this only. Okay. Now instead of this one, sometimes they can put silicon, but then only change will come the voltage here, because if you're charging with silicon, that will also take 0.7 volt. So accordingly, this charging voltage will change. Rest of the system is the same. Okay. So we'll see that one also. Now this is the negative clamper. Anyone has doubt, or is clear to everyone? Students, is that clear to
Yes.
everyone? Okay. बाकी लोग, निशा, शिविका, पलक.
सर
बोलिए.
वी आउट का फॉर्मूला आपने सर क्या लिखा था? वी इन माइनस वी एम माइनस वी बी.
हाँ, ये यहीं से निकलेगा फॉर्मूला, यहीं से निकलेगा. वी आउटपुट इक्वल टू ये वी आई इधर आ गया माइनस वी एम प्लस वी बी.
ओके सर, यही फॉर्म फाइनल है ना ये फॉर्मूला सर?
ये
हर
final-
जगह यही यूज होगा.
हर जगह ये होगा.
ओके, थैंक यू सर.
ठीक है, हर जगह मतलब इस सर्किट के लिए. Okay, so let us do now one more if you more things. Okay, so now what I did next time, you put up heading now positive clampers. Positive clampers. Okay, so positive clampers में क्या हो जाएगा? Now you have to keep diode like this, and this is the positive clamp. First time with only diode. We will do with only diode. Now this is diode. Okay. Now again, first you will decide what is the value of VC here, because now this time current will pass like this, so it will charge. Okay, so and it will charge up to the, because there is no other source voltage source here, so it will charge up to the maximum voltage. So this will come to VM directly. Okay, once it is charged fully, again it is open. Rest story same. Okay, कुछ करना ही नहीं है आपको. ये again you write the equation minus VI minus VM plus V naught equals to 0. So V naught become VI plus VM. Okay, now just keep on putting the values of input. Okay, when V input is 0, this is VM. Then here it is VM. Maximum VM. Okay, when V input is VM, it go to 2 VM. Go 2 VM. Okay, so start like this. When थोड़ा नीचे करना पड़ेगा. Okay, so it is go to up to 2 VM. Okay, up you please draw properly. So this is go up to 2 VM. Again it goes to 0, it will come here. Again it goes to minus VM, then it will go to the 0. Again it will come like this and go here. V input equals to VM sine omega t. If it goes to here, it will come to here. Okay, so and if it comes to 0, again it will come to here, VM. So now this time signal is shifted by VM. Now it's a positive clamper, current is going like this, so it gets shifted by like this. Okay, but the difference of signal from 0 to 2 VM is always, height is 2 VM. Here also height is 2 VM. This will not change. This is a positive clamper. Clear? Now you can do further cases. You can put here batteries again, plus battery, minus battery, and you see what happening. Okay, so this is my diode, and now you put a plus battery here, plus VB battery, and tell me what will happen. First thing is you to decide how much VC will come and which direction VC will come. बताओ कितना VC आएगा? BC always charging तो diode की direction में होगा. Tell me what is the BC value? What is the value of BC? Tell me. So when this current is flowing, this is short circuit. Okay, tell me how BC. I'm writing V input here. This is my minus plus. I'm putting sine wave, but later we will change that. But I'm starting with minus V input. Okay, minus V input. But it is a signal, so let it write minus V input minus VC plus VB equals to 0. So VC will come minus VI plus VB, and you take peak voltage, so VC will come minus VM plus VB. Okay, so minus VM plus VB, it will charge up to like this. Okay, VC. So now write the output equation. So now once it is complete charge, this become open. Again you write minus VI minus VC, that is VM plus VB. Okay, and plus V output equals to 0. So minus VI plus हमको we want V naught. So V naught will be VI plus minus VM plus VB is the equation. Okay, now see what happens. Put the values of input. So input is, when input is now, it's a positive clamper, it will go up. How much will go? It will decide like this. So when V input is 0, okay, this is minus. Huh?
Sir, I think the
this-
voltage across capacitor will be minus of VM plus VB.
How much?
Minus of VM plus VB.
Just let me decide. So we started minus minus VM initially. Okay, like this. Oh, we are going like this. Okay. So we are going like this, plus minus, so plus plus VM. Okay, and here battery was like this, na, minus VB, and then is plus VC. So VC will come.
सर एक बार डायोड बना के थोड़ा समझाओ ना, बीच में थोड़ा सा मिस हो गया मेरा भी ना.
Okay, so first let us discuss what is happening. First thing is, here we have a diode. This is my, I put negative or positive first. I forgot. Okay,
पॉजिटिव ऊपर था सर, ठीक है, आपने सेम बनाया है.
correct. Okay.
यस.
Now we will to see how much it gets charged. Okay, so it will charge like this only. Negative cycle it will charge. Okay, I forgot. Negative charge, it will only it will charge. So it will charging like this. Okay, it's charging. That means this will go. This we have to take minus maximum value. That is minus VM. This is minus VB. This becomes short circuit. This is plus VC. Plus VC equals to 0. So VC will go VM plus VB. Now it is correct. VC go VM plus VB. Okay, so now let's charge up to VM plus VB. Okay, now you forget this everything. This become out of the circuit, and now you write one more equation here. So now you can write minus V. Again you can write now. Now you can choose like this. You can choose like this now. Minus VI. Because while you to see how charging that, you have to see you're taking negative cycle or positive cycle. That time you have to decide what VC will come. Okay. So now this is minus VI minus VM plus VB and plus V naught equals to 0. So V naught equals to VI plus VM plus VB. Okay. So if it is 0, it will go here, somewhere here. This is say VM plus VB, VM plus VB. And it was when VM, it will go up to 2 VM plus VB. Okay, so it will go like this. it will come 0, it will come here. And when it is what? When it is minus Vm, so then it will go up to Vb, only up to, it will Vb here, up to Vb, up to here Vb, okay. And again it will go, when it is 0, it will go here up to this level, okay. And then it is plus, then it will go further this one to Vm, okay. And for 0 again it will come to like this, okay. So now in a earlier case it is Vb greater than this is the Vb. So earlier it was shifting by Vm upper side, now it should be shifting by Vm plus Vb. That is only, and difference to Vm minus plus Vb minus Vb is always 2m. Okay. And now if you put negative battery opposite here, if you put the same thing, you put here battery, now this like this, okay. So this will come here, this will shift in a 2 Vm minus by Vm minus Vb. So this you'll come here, so that is your homework, okay. This circuit is your homework, and you have to send me by plotting, you have to send me this circuit. This is Vb, okay. So only that you decide how much it will shift, okay. So how many circuits we have done? 6 circuits we done. This 6 only come in exam. It's easy to remember also.
सर गेट में आया था ये इस बार क्लैंप पर
क्या है था इस बार?
ये वाला नीचे मतलब डाउन वाला आया था, डाउन वाला जिसमें शिफ्ट लेवल डाउनवर्ड होता है, शिफ्ट वाला आया था.
So let us do एक दो प्रॉब्लम और कर लेते हैं. So Jinnah diode also used for clamping and clamping. The method is same. Okay, only you will decide how much VC is coming. ये सब में common है, okay. And RC should be greater than time period. So say this is your capacitor. Here I'm applying this time a square wave. The square wave means only value plus minus B, nothing else. This is 500 kilo ohm. This is signal is diode here, and you have to find the V naught. This is 10 nanofarad. Okay, and the input is given to you a sine wave. Okay, pulse of 1 millisecond is 1 microsecond, and again 1 millisecond. So this is 1 millisecond pulse fully. This is 1 microsecond pulse down, and again this is 1 millisecond. And you have to, this is your input, and now you have to plot the V output. Okay, tell me.
ये कैपेसिटेंस कितना है? 10 नैनोफैराड है क्या? एन
Now calculate the RC time. What is the RC time for this circuit? What is the RC? R into C. Tell me how much time is coming. R into C.
फाइव मिली सेकेंड आ रहा है क्या?
5 millisecond. Right?
यस.
If you calculate RC, it's coming 5 millisecond, and the time period is what? 1 millisecond. 1 millisecond plus 1 microsecond. Okay. So RC is greater than your 1 millisecond.
5 times greater.
Plus 1 microsecond also. You can take like this. Okay. 1 microsecond is nothing. Okay. So this will work as this circuit will work like clamper. Now again you have to find which direction it will charge, capacitor will charge. So obviously current is like this, it will charge like this. Okay. So current will not go through here. Current will always choose the smaller path, because here it becomes short circuit, so current will always go from here. Okay. So when current goes from always here, now next time what will happen? This will get charged, okay, up to plus VC. and this is only plus minus V input is what, plus minus only value. So I'll take maximum value of this one. Okay, and when the charging is a short circuit, so in this loop no voltage is going here, so VC will be what? VC will be charged up to the is value. What should I write? VM or what should I write here? V not VM. I like this up to VM. So it will go up to VM. Value is given what? 10. Value is given 10 volt. 10 volt or negative. Okay, whatever is given, value is 10. 10 volt pulse. 10 volt pulse. 10 volt pulse. Okay. So it will charge up to 10 volt. And once it's charged, this become open, and V naught will be across this resistance. So you can apply again, say minus well minus 10 volt, because it's a 10 volt and 0 volt. So let us write positive cycle. So that minus V input. Okay. And again, this is your plus 10 volt, and this is V naught equals to 0. So V naught will be 10 minus 10 VI minus 10. Okay. So when VI is 10 volt, you get 0 volt, 0 up here. You got 0 output. ये समझ में आ रहा है? Is it clear? Because the pulse now 10 and 0, and when it is 0, V naught is what? How much? When it is 0,
minus 10.
minus 10. Oh, short period. Minus 10 volt. Okay. So now this become your pulse. Now the pulse gets shifted. Why? Because this is a negative shifter. The current is flowing this one negative shift signal. So it's going negative shift up by 10 volts. That's it. 10 volt. क्लैंपर तो आसान है, आ जाना चाहिए तुमको। पता नहीं इस ट्री को स्टूडेंट को किसी भी कंफ्यूजन होता रहता है। Okay, so you draw 2 cycles. Okay, let me do one more problem. Last problem of camper. Okay.
Excuse me, sir.
Tell me.
Sir, your voice is not coming properly.
I hope this is fine now.
Yes, sir. Fine.
So is there any student who is not getting this one? Tell me. I'll repeat one more problem. So say you have a capacitor here, 10 microfarad. Here say a 10 ohm resistance. See here, this is silicon. This is 6.8. Okay. And V input is again a sine wave. So square wave. Minus 14 to plus 14. Plus 14. Minus 14. Plus 14 to minus 14 volts.
सर R 10 ohm में 16 ohm में
10 ohm. You can put 10 kilo ohm also, no issue. Okay, put 10 kilo ohm. And it is very high. Now, tell me what will happen. When positive cycle is coming, what will happen? So here you have to remember your diode. This is silicon diode. and this is Zener diode. And Zener diodes behave like a ordinary diode in the reverse cycle. Ordinary diode in the reverse cycle, you can take it ideal. Okay, for reverse cycle, you can take it ideal. Okay. Now, current will conduct in this direction, obviously, because this will conduct in the positive cycle, and this will also conduct in the positive cycle because this is Zener diode. Okay. So conduction will take place only in this direction. So this will charge only. It will voltage will come here, and voltage will come here. Now let us again see if it's charging like this. I'll take my V input here. So I'll take minus VP minus whatever value is there. Okay. So let us say plus minus V naught. Okay. Call this V naught. This is minus V naught. Minus V naught. I'll take VC here. Okay. Here it will be replaced by a battery of 0.7, and here it will be replaced by a battery of 6.8. So 0.7 plus 6.8 equals to 0. So VC will come now. V naught is minus plus 14 minus V naught is 14. V naught is 14. 14 minus ये कितना हो जाएगा बताओ? 6.8 and
7.5.
7.5. So it will come how much? 6.5. So it will charge up to now 10 microfarad capacitor will charge up to 6.5 volt. Okay, and once it is charged, the story same. This will become open. Okay, and this will become open. So you have to now, this is V naught. You have to write the equation like this. Okay, so minus V naught plus 6.5 volt plus, so minus 12 minus 14 plus 6.5. V naught equals to 0. So V naught will be 14 minus 14 plus 14 minus 6.5. 14 minus 6.5. Or you put V naught here, not put minus. We change this from minus to plus. Na? It will go plus V naught minus 6.5. Now when this is a 14 positive cycle, output will become how much? 7.5. And if it is negative, so minus 14, so 20.5. Okay. So now if you draw the output, so this is your equation.
सर वो दोनों बीओ हो गए हैं, वो बीआई क्या उनमें से एक?
ये इनमें से V आउटपुट है, और ये क्या बोलते हैं? VP बोलते हैं ना, फिर V आउटपुट है, VP बोल दो, VP minus VP.
अब ठीक है, यस.
Now put the values and draw. So this is the equation I'm writing here. V naught will be VP minus 6.5. VP is the maximum value. Okay, and here, put value here. This is 14. That will go 7.5 here. 7.5. There is a minus 40 to come. Minus 20.5. Minus 20.5. So this was clamper. So now let us do the next thing. So I'm erasing this one. Now, some of logic gates also can be implemented using only diodes. Okay, so put the heading now. Implementation of logic circuits using diodes. Diodes. So we can perform OR gate and AND gate using these diodes. Okay, so let us start with OR gate. How to perform OR gate function using diodes. So you have, say, one diode. There's some input here. There's one more diode. It has some input here. Say input 1, say A, variable A, say variable B. Okay, inputs. It can be high or low. Okay, so A can be high or low, 0 or 1. So it can be 0 or 1. Okay, or 0 or 1 means high or low. So it can A and B can take 0 or 1, and one values I'm giving 0 or one value I'm giving a B. So you can apply here B volt or 0 volt, B volt or 0 volt. Okay. Similarly, A can be 0 V, and similarly B can be 0 or V. That much voltage you can apply. And here, let me put a resistance here. Say a resistance here, and this is connected like this, and I'm measuring the V naught here. Output I'm measuring here. Now this circuit will act as a OR gate. Okay, so what is OR gate? So if you have two variables, say A and B, so OR gate function is A plus B. If you put 0 0, it will come 0. If you put 0 1, it will come 1. If you put 1 0, this will come 1. And if you put 1 1, it will come 1. This is my OR gate. Okay. Now let us see what happens here. If I put a resistance here, okay, let us see what happens. So if I say this is both are 0 0, okay, if both are 0 0, then what will happen? Tell me. If this is 0 volt, this is 0 volt, and this is 0 volt. So this diode is off or on?
दोनों
Off.
ऑफ रहेंगे सर, दोनों ऑफ रहेंगे.
दोनों off रहेंगे. So
Yes,
V
sir.
out, so no current is flowing through the resistance.
जीरो हो जाएगा आउटपुट.
Voltage 0. Okay. So if you say A B, okay, 0 volt, 0 volt. So V naught is also 0 volt. Okay, I am putting 0 here. This is in volt. This is in a volt. This is in volt. Okay, 0. Second case, I am putting 0 1. This is 0 volt, and this is a 5 volt. 5 volt or V volt. 5 volt. Okay, this is 0 volt. This is the V volt. So output will come how much? If this is the V volt and this is the ideal diode, is an ideal diode. So this voltage, this is ideal, this becomes short circuit. So this V will come here. Okay, and this become this is high voltage here and here 0. So this become open circuit. Okay, so how much coming V output? V? Yes or no?
Yes, sir.
Okay. Similarly, now the next is you put V0. This is V and this is 0. Okay, so this time now this will be open, this will be short circuit, this will be V, so this will be V again become V. Okay, if both are VV, then both diodes are conducting. So this V will come here, this VV no issue. VV is same here, and V is coming here. So this V volt, V volt, V is coming. So this circuit, what I have drawn, okay, this question came in TFIR. So this gate, this circuit is implementing your basically OR gate. Okay, is that clear to everyone?
Yes, sir. Clear.
Okay. Now let me do a few more problems on this same concept. Now I am putting here, say again the same circuit. I am putting a diode here. I am putting a diode here. Okay. Say here I am putting say 3 volt, and here I am putting a 1 volt, say 1 volt, 1 volt. Okay. And I want to find how much current is flowing through the circuit I. Okay, and the value you can put this is as a 1 kilo. How much current I is flowing in this circuit? Now tell me, both diode are conducting or one is conducting? Tell me.
One.
Only one will conduct.
Only one will conduct, because suppose if this will conduct, then this will become short circuit, and the 3 volt will come here. 3 volt. So if it is 3 volt comes here, this will automatically become a reverse bias. Okay. But if I say no, this is conducting, say this is D1, and I say this is conducting, this is not conducting. So is it possible? If I first thing, if I say both are conducting, if I say both are conducting. So if I say both are conducting, now this 3 volt coming here and this 1 volt coming here, this potential cannot be same. Okay. So both conducting is not possible. Both conducting case is not possible because this potential cannot be same.
Cannot be
Okay.
different. Cannot be different or same.
They cannot be different. Right?
Yes. Yes. Yeah.
One cannot be different. Okay. So this is not possible. If I say both are open, so let us find this VD1 and VD2, and I say both are open, and I find the VD1 and VD2. So what I find, this is no current is flowing, this is 0 volts, this no drop is there. Okay, so this is grounded. Now VD1 is how much? VD1 is my 3 minus 0, 3 volt. It's saying it is a positive voltage coming, so you cannot say this is open. Okay, similarly, this is coming 1 volt. So I'm telling you open, but VD1 and VD2 both are coming positive. So this case is also not possible. Okay, now the next case is I say this is conducting, this is not conducting. So if I say this is conducting, this will come 1 volt, here 1 volt, this is 1 volt, and here 3 volt. So this is also VD1 is positive. VD1 is positive. So this cannot be open. You have to see all the cases. Why higher voltage on? Now if I say this is on and this is off, then this coming 3 volt and 1 minus, this is perfectly fine because now VD2 is coming negative.
Yes, sir. Yeah.
Okay, so you have to check all the cases. Okay, I'm repeating again one more time. Don't mistake. Okay, this is my diode. This is my diode. Okay, now which diode is conducting? I want to check. Okay, I say both are open. When I say both are open, but now this is become 0, no current flowing, this becomes 0. So this VD1 is also positive, VD2 is positive. I'm saying open, but the bias voltage is positive. This is not possible. When I say both are conducting, then what happening? Same, this volt, 1 volt and 3 volts coming here. That case is also not possible. Okay. If I say this is open and this is short circuit, this is conducting, so 1 volt is coming here. This is 3 volt, this is 1 volt. This making this diode also forward bias, so this is also not possible. When I say this conducting and this not conducting, so this 3 is coming here, so automatically this is a reverse bias. This is a reverse bias. Okay, So this is the key, correct. Now here voltage is 3 volts, so I will be how much? 3 volt divided by 1 kilo ohm, that is 3 milliampere. Is that clear to everyone?
Yes, sir.
So Pandika,
Clear, sir.
now let me put some more values. Say here a diode is there, here one more diode is there, here one more diode is there. Say this is 3 volt, this is 2 volt, this is 1 volt connected here. Say here minus 5 volt is connected. This is all connected here. Okay, this is again say 1 kilo ohm, 2 kilo ohm, this time 2 kilo ohm. Okay, find the I in the circuit. Find the I.
फोर आ रहा है क्या?
So again, if I say this is conducting, so automatically this will not conduct, this will not conduct. Okay, so this will conduct. Okay, these will not conduct. Okay, if you can check all the cases, all cannot be open, all cannot be conducting. Okay, so only one will conduct. If I say this conduct, then some contradiction will come. So you have to remember only higher voltage will conduct. Okay, so this will be conducting. Okay, so this conducting, this become 3 volt. This is reverse bias, this become reverse bias, and this is 3 volt. Okay, so this all are 3 volts, 3 volt, 3 volt, 3 volt. So this making this reverse bias, this is open. Okay, now this is the case. Okay, so voltage drop is how much? Voltage drop across this one resistor is 3 minus 5. I will be how much? Divided by 2 kilo ohm. So this become how much? 8 upon 2. That is 4
4
milliampere.
milliampere.
4 milliampere. Okay. So whenever diode are conducting this way, always higher will conduct. And if you're applying 0, same voltage, so whatever you're applying, suppose you're applying 5 will come to, this is basically your OR gate. This is 3 variable OR gate. Okay. Now let us take AND gate.
सर ये उसके एप्लीकेशन है क्या और गेट के थ्री वेरिएबल?
हाँ, ये 3 वेरिएबल भी हमने पहले क्या किया, 2 वेरिएबल OR गेट किया था ना,
यस सर.
तो एंड वेरिएबल भी कर सकते हैं ना, जितने डाटा होगा उतना वेरिएबल.
हाँ हाँ यस सर. या यस.
Now you say my diodes are connecting like this. I'm putting 2 variable AND gate. This is my A, this is my B. I am putting a higher voltage here, say B plus VCC, say plus VCC. Okay. Here resistance is there. Here resistance is there. Okay. And this is like this. And I'm measuring the say B naught, I'm measuring here. Okay. Here I'm measuring the B naught. Okay. And this resistance some R. Resistance is R. Now put the values. Let us see what is AND gate. So you have a you have a B, and you have a dot B. Okay, you have 0 0. This equals 0 0 1 0 1 0 0. Only 1 will come 1. Now let us put 0. Let us check it here. I am putting A in volts, B in volts, and I am putting here the output V naught, how much coming. Okay, so I say this is initially 0 volt, 0 volt. Okay. So if this is 0, this is 0, this is 0, both are conducting. Yes or no? Both are conducting. Both are conducting. Become short circuit. Okay. Tell me, this is 0 volt, 0 volt. What is the value of V naught? Tell me. What is the value of V naught?
जीरो हुआ सर कि ग्राउंड से कुछ रेजिस्टेंस नहीं है ना
Directly
ग्राउंड से है यस सर
directly connected to the ground. So V naught will be 0.
जीरो
Not will be 0. Directly connected to 0. This becomes 0. Okay. Similarly, if you say, so current will pass through like this. This is both short circuit. So current pass like this. Okay. Now you say this is 0 volt. This is one. This is higher voltage. This is VCC. I'm applying here VCC. I'm applying VCC here, or greater than VCC, whatever VCC here, and here I'm applying 0. So what will happen? This will conduct and this will become open. Okay. And now current will come here and current will go like this. Current will go like this. This is the ground. Again, the whole voltage will get dropped here, and here it will come 0 only, because connected to ground it will come 0 only. Yes or no? Because this voltage getting dropped here. Okay, so whole voltage getting, this become ground, this is ground, this is ground, so this is ground. So all voltage is getting dropped here. So this point is 0, 0, so this comes 0. Here. Similarly, next case, you put VCC here, you put 0 here, you come 0 here. At least one diode is conducting. Okay. Now you say both the diodes are say conducting, and both the diodes are open. Both the diodes are open. This is also VCC, and this is also say VCC. Okay. Now VCC cannot make it conduct, so this become open, this become open. Okay. Now both become open. So how much current is in the circuit? So this current cannot go here. Okay, current will not go. Current cannot go here. Okay, current cannot go. So obviously there will be no current flowing. No current flowing here. So this voltage will automatically come here. No drop will there because no current can flow here. Circuit is incomplete. So this voltage VCC will come here. So when you give VCC, you got VCC. Just give me 1 minute. I check the circuit first. Yes. So like this, if you're getting confusion here, okay, let me put a V naught here. I'm measuring V naught here. Okay, this is open. You remove this one also. You're getting confused the circuit. Okay, getting confused here. You put circuit like this. Okay. Now what will happen again? You see, if this is 0, this is 0. Both are conducting. At least make it this ground. Okay. Now this conducting. So this 0 will come here. This ground will come here. You get 0 here. Okay. If one is conducting also, this ground will come here. Okay. Now if both are VCC, this become open. This become open. Okay. So current cannot go here. Current cannot go here. So here current is I0. So this voltage automatically come here. VCC. This is your AND gate. I think now it's clear. निशा क्लियर है कि रिपीट करूं वापस?
यस
क्लियर है ना?
हाँ जी सर
सर्किट ऐसे ड्रॉ करो. So this is your AND gate, implementation of AND gate. This is your AND. Okay. Now let us do one problem. Shikha, is clear?
यस सर
Now let us put like this. Say this is my 5 volt. Here diode is there. This diode is a, so here you have a 3 volt. Here you have a, say, 1 volt. Here you have a 2 kilo ohm resistance. Okay. You have to tell me how much current is flowing through the circuit.
सर डायोड एक नीचे डायोड नहीं है क्या?
Diode. So this is my circuit. Tell me how much is coming. How much value of current is there? Now again, you have to check which diode is conducting to decide. Tell me which diode should conduct. Higher voltage or lower voltage? Apply your own mind. Tell me which diode should conduct. D1 will conduct or D2 will conduct? Put all the cases. If I say both are conducting, can both conduct? If both are conducting, this 3 volt will
No,
come
sir.
here, this 1 volt will come. Both cannot conduct. Okay, so both D1 and D0, okay, cannot conduct. Both cannot be open because the voltage drop VT is positive. So both cannot be open. Both D1 and D2 cannot be open because this voltage coming here. You open this 5 being positive, this voltage is making positive. Okay. Let us say D1 is conducting. D1 is conducting. This will conduct. And this voltage will come here. 3 volt. So this says if you D1 conducting and this open, but again here voltage is coming positive. So this is also wrong. Okay, if you make this conducting, okay, so it said this is also conducting. And we disconducting this voltage and this voltage cannot be same. This is also not possible. That means D1. So only possibility is so D1. So D1, D1. Third case also wrong. So fourth case true. That means D2 is conducting and D1 is open. That is possible. If I say this is open and this is conducting, so I have no issue because this 1 volt will come here. This 1 volt will come here. So VD is negative. Okay. This 1 minus 3 volt VD is coming negative. So automatically this is making this open. Okay. So now this potential is 1 volt. So current I will be how much? 5 minus 1 upon 2 kilo ohm. That is 4 divided 2 into kilo ohm. That is 2 milliamp. Is this point clear to everyone?
सर ये वाला बताना एक बार लास्ट पॉइंट जो बताया आपने कैसे इसको कैसे ओपन किया इसको कैसे क्लोज किया एक बार
भाई अगर ये कंडक्टिंग है और ये नॉट कंडक्टिंग है, this become 3 volt here
यस सर
and this 3 minus 1 VD2 become positive.
यस सर यस
तो ये भी कनेक्टिंग हो जाएगा.
हाँ
ये
जो
क्या
कि पॉसिबल नहीं है दोनों एक साथ
possible नहीं है.
यस
Possible.
यस
If I say this is conducting,
यस
okay, this is not conducting. So this 1 volt will come here. This 1 volt will come
या
here.
यस यस सर
Diode. So 1 minus 3.
थैंक यू सर
So this is possible. Like that, you have to check. You have to find voltage across the diode always for each case. Okay, whether it is possible to both have positive or both negative, and like this you have to pull the cases. Okay, so you can find the current here. Okay, let me give you one more question. Okay, this is
सर
हाँ
सर इस केस में आपने 1-3 करके लिया है, 3-1 कैसे क्यों नहीं लिया सर? इसको
डायोड
ले
आपका
सकते हैं?
डायोड आपका ऐसा है ना,
यस
ये
सर।
वीडी कैसे लिखोगे, ये माइनस ये ना,
ओके
डायोड फॉरवर्ड बायस से रिवर्स बायस कैसे करोगे, यू विल फाइंड द वीडी.
यस सर।
So this is your okay. Similarly, if I put now say 3 volt, I put diode here, 3 volt. I put here 2 volt. I put here 1 volt, 1 volt. Okay. Tell me what is the current now. Which will conduct? Tell me which will conduct. Here
1 वोल्ट होना चाहिए ना.
only 1 volt. Only less will conduct. Forget
लेस वाला ये सर.
if you make this conduct, this become 1 volt. 1 minus making this negative, 1 minus 3 making negative. So you can make this conducting and this both open. It's possible. Okay. So here again, if you find the current I, so this will be conducting. This will be open. This will be open. Okay. So 5 is 1 volt. 5 minus 1 again the same thing. 4 2 million. Now there's one more last thing remaining in this.
मीन्स एंड और की सीरीज में और में हमेशा मैक्स वाला कंडक्ट करता है और एंड में लेस वाला.
That's one. AC resistance we have not discussed. Tomorrow we'll do some problem. Today we'll do this AC resistance and then we will. Now
Sir,
AC.
ट्रांजिस्टर इसके बाद आएंगे क्या?
Now next is there small signal small signal.
Sir, your voice is very low.
1 minute. The next is your small signal model of diode. Now it's coming. Voice.
Yes, sir, perfect.
Yes, sir.
So small signal model of diode. Okay, or you can write here AC resistance of diode. AC small amplitude AC resistance. Small amplitude AC resistance of diode. Now how diode will behave for a AC signal? Okay, so first let us see what happens with DC. Okay, so say I am applying a diode here. Okay, diode is some resistance there. I'm applying some voltage, say here V. Here voltage drop is say some VD voltage drop is there. I don't know how much VD is there. VD can be anything. Okay, VD can be 0, VD can be 0.7 if it is silicon. If it is designed in some other way, VD can be 2 volt, 3 volt, anything can happen. Okay, how you design the diode? Okay, PN junction, accordingly this VD can be anything. Now if I draw the IV characteristics for this diode, okay, if I say voltage across current across diode ID and voltage across diode is VD, okay, or V, whatever, VD, okay. So obviously my diode will start conducting here at this point. This is my diode. My diode, okay. Now since I'm applying say IV, okay, I flowing the diode and you're applying voltage here, So IV. Now at a voltage VD, is a voltage VD which across diode. Here it will start cut off. It's from this here conducting. Now you're applying some voltage VD here. A current ID will be flowing. Okay. If it is VD here, a current ID will be flowing. This is your voltage you're varying. So when you're varying the voltage, obviously this voltage drop across this is also varying. Okay. Now say for voltage say VD, a ID current in the flowing circuit, because this may be, so if you put VD here, there's a drop voltage here and there's a current flowing through this one, automatically this is the same circuit here. So don't get confused with this V. This is the applied voltage across the diode. Okay, so for say voltage drop is VD, then the current is flowing ID. Okay, now if I want to find the DC resistance of this diode, DC resistance of diode, okay, DC resistance diode, that will be simply R, how much? VD upon ID. This is the DC resistance, okay, of diode. Now say if I'm applying here a AC source, then what will happen? If I'm applying AC source to diode, then what will happen? Then how to find the AC resistance? Okay. So let us say now I am along with this DC source, I am putting a small amplitude AC source also here. Okay. This is a VAC, VI equals to Vm sine omega t, where Vm is very small, millivolt, small, okay, in millivolts. So along with this diode, I'm applying some AC source also here. Okay. Now say what will happen. So let us understand this way. This is my diode. Okay. I applied a voltage V, which is giving you drop VD here. Okay. So this is my operating point. This is a VD here, and I am getting a current ID here. Okay. This is my DC resistance. Now what I'm doing, I am giving a sine wave. So if I'm giving a sine wave, automatically what will happen? The applied voltage will increase, yes or no? What will the applied voltage now? VD plus VI. Okay. If you're getting confused, you remove this one. Now if I'm applying this source plus this source, okay. Now the voltage across this VD is what? VD plus VI.
Yes, sir.
And VD plus VI means VI is sine wave. So for half cycle it is a positive, half cycle is negative. That means
Negative.
now my VD is increasing going here, and then VD is going here. So my current will, when VD is slightly increasing, so my current will also increase slightly, and my VD is decreasing. My VD is decreasing here. My current will also decrease. So my current will oscillate from here to here when my voltage is oscillating from here to here. This is a very small amplitude. Only you can apply this amplitude. So so this is a DC bias. This is called DC bias. So say some DC bias, and you're applying some AC signal. So because AC signal, this VD will change little bit. So current will also change here. Okay, and this is your main point here. So say this is your main point. This is another point here. So basically, when you are superimposing a AC signal to on your this one, okay. So it getting either add or decrease. Okay, so accordingly, what letter you will get here? Sine amplitude. Sine amplitude like this here. Okay. So here you can calculate AC resistance RAC. So RAC is basically delta VD upon delta ID. Are you getting my point? If you're applying DC source, you have a fixed point, fixed operating point, and you can measure the DC resistance by simply V by what is the voltage of the diode, how much current is flowing through a diode, the ratio you can find, and you can find the DC resistance. If you're putting AC amplitude, okay, so there is a now delta VD here, and delta ID here, okay. The ratio will give you the AC resistance, and the AC resistance value I want to find, okay. So let us find what is the value of AC resistance. So always you have to apply superposition principle. When two sources are there, DC and AC sources cannot be analyzed simultaneously. We'll see that one later. So now I want to find the AC resistance. So I know the current flowing through the diode is given by IS exponential. Okay. What is the formula? QB upon eta KT minus 1. This is the formula for your this one diode. Okay.
Sir,
Now
what you have written there?
exponential QB
No, there RAC equals to.
RAC
Okay.
delta and del VD upon del ID.
Okay, sir.
Okay. Now just differentiate this equation and find the AC resistance value, how much is coming. Now this ID current is flowing in the circuit. You're applying some voltage VD here, and a current is flowing ID. Okay. Find
सर वो क्यू है क्या एक्सपोनेंशियल क्यूबीडी क्या
QVD upon eta KT. Diode equation. Eta KT.
क्यू आता है क्या ऊपर ठीक
क्यों आता है ऊपर?
ठीक है
There's a diode equation. Diode equation. Okay. Find it now. Differentiate this equation. So you differentiate this equation, this become delta ID upon delta VT. How much come? IS. Okay. This becomes 0. Exponential come exponential QVD upon eta KT. Okay. And if you differentiate this part, it will become Q upon eta KT. Okay. Yes or no? And this, how much you can write? And you want to write this one, at this one. Okay. Multiply this one. So this I can write ID plus IS from this expression. Okay. Putting this value from this equation. This will become ID plus IS Q upon eta KT delta ID upon delta VD. Are you comfortable with this one?
यस सर
Other student? I can write this like this now
Yes, sir.
from this equation.
Yes, sir.
Now this is the ID is a forward current. ID is forward current. Forward current. Okay. And IS is reverse saturation current. Reverse saturation current. Okay. Now your ID is always greater than IS. IS is in microampere. This is in milliampere. Milliampere. This is in microampere. So I can always neglect IS compared to your this one. Okay. Now I can write delta ID upon delta VT will be equal to Q upon Q into ID eta KT. Okay. And I want to add AC resistance, that will be delta VD upon delta ID, that I can write, and KT upon QID. Okay. And okay, and eta, okay, KT by Q upon ID. Okay. And KT by Q is called thermal voltage. This is called thermal voltage VT upon ID. Okay. So now the formula for RAC become eta VT upon ID. Okay. where VT is your KT upon Q thermal voltage. Thermal voltage. Thermal voltage means this is the thermal temperature equivalent to voltage. Now, if you put a value, your temperature, this is the Boltzmann constant, this is the charge of electron, and this is the temperature. Okay. If you put this the value of temperature, this will give you equivalent voltage. Okay. And at room temperature, at 300 Kelvin, okay, the value of VT is 26 millivolt. If you want, you can check. We can calculate. Okay, we'll calculate now. So VT is the KT is what 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. T is temperature, say 300 Kelvin. Okay. 300 Kelvin. And Q is a charge of electron minus 19. Okay. Tell me how much value is coming.
पता नहीं क्या लिखा है 1.36 into 10 raised to power
1.38.
okay 1.38
This is a Boltzmann constant, na KB.
okay
23 joule per Kelvin. Tell me what is the value coming for VT? How much is coming?
25.8 millivolt.
Yes. So almost it will come either 25 millivolt or you can take 26 in 20. Generally we take 258 millivolt. We take this is actually 258 millivolt. So I take it is 25.8 millivolt. We take almost equal to either 26 millivolt or sometime in question it will equal to 25 millivolt. Okay. So generally we take this 26 millivolt, but sometime it will tell in the question that is 25 millivolt. That time you put 25 millivolt. Okay. So now what is my AC resistance? So AC resistance, small AC resistance. Okay, small AC resistance, Okay. Formula is how much VT is at room temperature at 300 Kelvin for ideal diode. So when diode is ideal, eta is 1. So my RAC will become 26 millivolt upon ID, and ID is generally given in the milliampere. Okay. So that means first I need to find how much ID is flowing in the resistance due to DC source. This is because DC source. And then I will use this formula to find when I'll apply AC, how much resistance diode will show can be calculated for this equation for ideal diode. If it is silicon, then what will happen? Eta become 2. Okay. For silicon, this is true for ideal diode as well as true for germanium. For germanium also eta is 1. For silicon, you can write RAC equals to, this is multiplied by 2, 52 millivolt divided by ID. Eta equals to 2 in the question that is given.
Sir?
So, tell me.
Sir, this RAC is different from RDC.
Yes, this is RDC. DC resistance is different. DC is simply how much voltage, how much current ratio. Okay. And AC and small AC resistance is this one. 26 divided by ID. Millivolt divided by ID.
But sir, then what is the significance of this RAC?
We'll do it. Yeah, we just now shown na. See, whenever you apply DC and AC source together, okay. So DC will give you fixed resistance, and now you're applying AC. If you apply small input AC, then the current is varying, na. Voltage across diode varying, current also varying. So some changes coming. So some changes coming means there is some resistance. Okay, some extra resistance. That extra resistance we are finding here. Okay. I'll do one problem, then you understand. So what does this mean? Okay, I'll do one problem. And
Sir, what is eta, sir?
Eta is the diode constant.
Okay.
Eta, yeah, I have written one time now. What is eta? Tell you. Just tell me. Actually, this one, give me 1 minute. I also forgot what is eta. Just I'll tell you. Eta is ideality factor. Okay, ideality factor. Eta is ideality factor. How much is deviating from ideal behavior? Ideality factor.
सर सर ये पिक्चर में ईटा पिक्चर में इंट्रोड्यूस क्यों होता है, मतलब ईटा को हम क्यों लेते हैं, कुछ रीजन इसके पीछे का?
रीजन क्या है? जैसे नाम बोलता रहा है कि आइडियल को अभी ईटा जो आइडियल बिहेवियर कर रहा है,
हाँ हाँ
हम उसको वन बोल रहे हैं, वन बोल रहे हैं, तो
हाँ,
आइडियल डिफरेंट तो उसको टू बोल रहे हैं।
यस यस यस।
क्योंकि वो जब करंट को जब सिमुलेट करते हैं उस फॉर्मूले से, ओके, तो उसमें कितना फर्क आ रहा है, उसके लिए एक रेशियो उसमें एक्स्ट्रा ऐड हो गया
तो
है,
एक्सपेरिमेंटल हमने पैरामीटर डाला है आफ्टर एक्सपेरिमेंट करने के बाद।
सिमुलेशन तरीका है कुछ करके,
हम्म।
ठीक है। लेट अस डू वन प्रॉब्लम। क्वेश्चन इज obtain the static DC मतलब static resistance, static, okay, and dynamic resistance, AC का मतलब dynamic, and dynamic resistance of a PN junction। PN junction का करना है, दे रखा है, जीना डायोड है, जर्मेनियम डायोड है। So you have been given temperature of PN junction is given 27 degrees centigrade, okay, temperature is given, and reverse saturation current IS is given to you 1 microampere. This reverse saturation current value is given, this one, and this given this germanium diode, germanium PN junction. So eta value is given 1, okay, and the applied voltage across diode is given 0.2 volt, 0.2 volt, and the Boltzmann constant, you know, it is 1.38 to 10 raised to power minus 23 joule per Kelvin. Okay, now you have to find both AC and DC resistance of the diode.
सर बीडी जो है वो डायोड वोल्टेज या अप्लाइड वोल्टेज?
अब डायोड वोल्टेज हमेशा डायोड के अक्रॉस ही होती है, अप्लाइड वोल्टेज।
हाँ यस सर यस।
दिस इज अप्लाइड वोल्टेज, सोर्स का वोल्टेज नहीं है, ये अप्लाइड वोल्टेज है डायोड के, बिकॉज applied voltage say you can decide like what is current in the diode, okay. When I write the current ID in the circuit, I write IS exponentially QV upon eta KT. Here applied voltage across diode, how much voltage is across diode and how much current flowing in the diode, okay. This is not a source voltage, this is the voltage how much is coming on the diode, okay. So and eta for this given question, eta is 1. So you want to find the dynamic resistance, static resistance. Static resistance is simply VD upon ID. Okay. So VD is given to you 0.2 volt. ID you want to calculate from this equation. Eta is given 1. Find out how much ID is coming. So ID will be IS value is given to you 1 microampere exponential QVD upon temperature is 26 degrees centigrade, that is 300 Kelvin, room temperature. So you can take this KT upon Q, okay, because this become VD upon VT. KT upon Q, I can write Q here, is VT, this is a -1. So this is a 1 into 10 raised to power -6 exponential. This is 0.2 volt, 0.2 volt, okay, or 200 millivolt, 200 millivolt, and this is how much? 26 millivolt. For simplification, you can take 25.
Sir?
Yes.
Sir, why you are taking Q is equals to 1?
I didn't take Q equals to 1. I took KT by Q. I put Q down.
Oh, sorry.
Okay, so this becomes VT. This formula is basically, you can write this formula as ID equal to IS exponential VD upon VT. This that VT is what? Thermal voltage. If eta is 1, you can put here like this VT. Okay, and VT is how much? 25. I'm taking for simplification, I'm taking 25 millivolt. So millivolt cancel. 25, how much will come? 8. So this is exponential. So how much coming? 1 into 10 raised to power minus 6 exponential 8 minus 1. Tell me how much coming? How much current is coming?
2.979 milliampere फाइनल आ रहा है ID
ID कितना आ रहा है? 2 point
2.979
जो भी आ रहा है. Okay. So if you take 26 here, the answer will come different. So finally you are saying milliampere na, how much? ID how much?
2.979
2.97. Other student please check. Milliampere na?
हमने 25 लिया है मिलीवोल्ट तब आया है
Milliampere na?
यस मिलीएम्पियर आ रहा है
This is a milliampere. Now you can put the value here. This is 200 millivolt, and you can put here 2.97 milliampere. Okay, so this is milliampere, millivolt. Cancel out. Divide 200 by 2.97. This will give you the resistance, DC resistance. How much is coming DC resistance?
67.13 आ रहा है 67.136
136 ohm. And find the AC resistance. AC resistance के लिए you want DC. So whenever you do small signal, first you have to do DC analysis, then you have to do AC analysis. Okay. Now what is AC? AC resistance. So AC resistance R AC equal to eta VT upon ID. Eta is here 1. So RAC become 25, 26 exactly. I have to put 25 na? Question. If I say question, I'm taking 25, then millivolt upon, that is 2.5 to 10 raised to power minus 3 volt upon ID is 2.9. How much? 2.9?
979
979 milliampere.
और ये आ रहा है 8.392 ओम आएगा
8.392 ohm.
8.4 कर सकते हैं राउंड ऑफ करके
So this is the difference of AC and DC resistance. Okay. DC resistance, simply applied voltage, how much current is there? Ratio of VT by ID, and AC resistance of the diode is this one. Okay. Tomorrow we'll do some more problem to understand this concept clearly. Okay. So I'll stop here. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
थैंक यू सर